Welcome to DevNetwork's Developer Week webinar series. I'm Patrick Gallagher, and I'd like to welcome all of you to this week's featured webinar presented by NGINX. Get the most out of your APIs with Microservices-Friendly API Management. NGINX is a regular sponsor of Developer Week events, and they, along with F5, enable organizations to get the most out of their API ecosystem. Before we get started with speaker introductions, I'd like to remind our attendees that live chat and Q&A is available during the session, and you can raise your hand in chat or ask and answer questions in the Q&A section of the webinar viewer. Also, this webinar will be recorded and made available within 24 to 48 hours for additional viewing. Make sure to tell your coworkers to check it out. Joining us today as your presenter from NGINX is Alessandro Garcia. After gaining experience as a platform integration engineer at NGINX, Alessandro now spends his time as a technical marketing engineer, empowering engineers in their journey to stay ahead of the curve by using the latest tech offerings. So, without further delay, please give your undivided attention to Alessandro.
Thank you for the introduction, Patrick. So before I get properly started, I just wanted to quickly mention there'll be 3 polls sent throughout the presentation, and just feel free to answer them as you see fit. And then we might briefly go over the results if there's time at the end of the webinar. And with that being out of the way, I want to start by going over a very simple concept, namely, what is an API? So, what indeed is an API? Well, let me use an analogy by means of a brief history lesson. To do that, let's go back in time to the prehistoric era. Back in the good old days, we as humans had to learn how to hunt and consume prey. And to do that, we developed some tools such as Access. As you can see the guys in this very nice picture we're using. And you might be wondering, what does that have to do with APIs? Why not? Well, the real thing is that the situation these guys were finding themselves in is not that different from the situation that we overall as humans, as consumers, have when we try to access data. So if we think about humans as consumers, and the prey that we're trying to hunt is the data, well, turns out the relationship our ancestors have with prey is not unlike the relationship consumers have with data. And where our ancestors had access to which help them consume the prey, we have APIs to help us consume all sorts of data. But maybe this is not good enough as an explanation for you guys. So, let me Google that for you. Let me Google what an API is. According to Google, an API or an API endpoint is a set of functions and procedures allowing the creation of applications that access the features or data of an operating system, application, or other service. Or in simple terms, developers provide dedicated URLs that are optimized to return pure data to requesting clients. So to make another analogy again, it's the same way you have a web client such as Chrome or Firefox or Internet Explorer, sending a request to a web server that then returns some HTML, which is what you're seeing in your website. Well, you also have an API client that sends a request to an API endpoint, and the endpoint then returns some data in some format. Format can be JSON, it can be XML. There's multiple ways of showing that data. Just to show you guys a real quick example of what that data usually can look like, I sent a simple request to a Pokemon API to get information about Ditto, one of my favorite Pokemon. And as you can see, I used the JQ tool. It's a tool to parse some JSON data to filter the results and figure out what the type of Ditto is. In this case, the type is normal. And you can see this API, for example, uses JSON as its data structure, but there's other data structures. XML is a very popular alternative to, even though it's starting to wane down in its popularity. Okay, so now that I've gone over what an API is, there should be a poll showing up on your screens right now. If you want to query, select how many API calls would you say are critical to the day-to-day operations of your business, which you'll see why in a second. Okay, so yeah, now that I've gone over what an API is, and while I'm doing this, feel free to fill out the poll. And I'm showing you a quick example of what an API is. You might still be wondering what's with all the fuss around APIs. Well, first, APIs are very important because they help unlock data by easing access to the information. This goes two ways, really. First, you can let your users or customers easily build integrations around your product. And second, you can improve cross-team data sharing and collaboration between the various teams or departments that may exist within an enterprise that will usually not work together. What this really means is that, say you have a public API, such as that Pokemon API I just shared. Well, if that's your product by some way or shape, you can let your customers build integrations around your Pokemon data very easily. Or if you're in a very big organization and you have various teams, maybe those teams will usually not talk much about amongst themselves and will not be able to share the data that they're working with. By wrapping the data those teams work around an API, suddenly it becomes so much easier to share the data cross-team, cross-functionally. The second major driver for API adoption is that APIs play a key role in the microservices world. APIs enable microservices components to seamlessly communicate between each other. And APIs are really simple to work with, which makes it so much easier to provide better fault isolation and resiliency within your microservices. Not to speak on how easy it becomes to scale your microservices if you put an API in front of them. And finally, the really major driver for API adoption at the end of the day is that they provide new opportunities to generate revenue and build partnerships with third-party developers. And in fact, there's entire business ecosystems that are built around APIs. We've all heard about PayPal, Expedia, and many other examples that are literally just based around selling access to their APIs. And it should really come as no surprise then that according to Programmable Web, a leading source of news and information about internet-based APIs, since January 2015, an average of more than 2,000 APIs has been created per year. And well, this chart is from the latest survey, which was done around June 2019. So if the trend keeps going up the way you see in the graph here, well, you're almost growing linearly, but even really undergoing a massive explosive growth, which really drives me to the next question, which is that now that we have established why APIs are important, how do you make the most out of your APIs? And how do you make your API differentiate itself from competitors, especially if you're in a market where everybody is trying to be the best that there is and always fighting for consumer attention? Well, the answer to that is real-time APIs. And before I delve into this, I want to ask you guys, how long does it take for your API to process an end-to-end request, which will become very important soon when you guys see what I'm going to talk about right now, which is that real-time APIs are really key in developing your new businesses. Why is that? Well, latency, really. Real-time API is a high-performance API that takes around 30 milliseconds at the 99th percentile when processing an API call from client to endpoint and back, all while routing, shaping, authenticating, securing, and caching the API request. Because at the end of the day, as I was just talking, if you deliver a fast, responsive experience, your customers and clients will love to choose you before a similar sluggish API experience. And this is why I was sending poll right now. It's just to get some data, see how your API performs. Maybe you guys can talk amongst yourselves, or at least see how other people's APIs usually perform around which latency range. Because it's an important question, and one that's not often really talked about when talking about API gateways, API endpoints, APIs in general. Let me go a little bit more into why real-time APIs matter. Well, you see, in a world where 80% of orgs are undergoing digital transformation, and 83% of all web traffic is APIs, and well, these are stats for now, but they're steadily increasing all around. Well, real-time APIs matter mostly for the same reasons that drive API adoption, really. Number one is that if your product relies on selling access to APIs, real-time APIs help you grow your revenue. A high-performance API will make customers use your product instead of a similar, slower product. If you have two different APIs that can authenticate and just make secure transactions, payment transactions, and that's the reason that whoever is trying to implement such an API into product will choose the high-performance transaction API instead of the slower one. The second reason why real-time APIs matter is the customer experience. And this is very simple to understand, really. Faster APIs equal customers being able to use your product with shorter loading times. And once again, those customers will choose a product that is fast versus one that is not as fast. Third reason why real-time APIs matter is brand protection. If your API isn't performing up to standards, you can bet someone up there is complaining very vocally about your product, quote unquote, taking ages to do anything. We've all used something, an app or another like that before. And fourth and finally, the reason why real-time APIs matter is developer productivity. Within cross-functional teams where you're sharing data, like I was talking about before, well, real-time APIs enable those developers to get data from your APIs at a much faster rate. Under most circumstances, this won't be an issue. But if your product relies on real-time data in any way or shape, think a product that relies on real-time access to maps or Google Maps API, having real-time APIs will once again make consumers, or developers in this case, choose your API over other alternatives. And since here at NGINX, we really believe that real-time APIs are mission critical for our products relying on APIs, we've developed a simple tool to measure the latency of your APIs. So how do you know that your API is real-time? Well, enter RTAPI, short for real-time API. A lightweight real-time API latency testing tool that you can get from our GitHub repository. I've included the link in the slide. Feel free to check it out. It's open source. It's available to everybody. Feel free to even submit a pull request if you so wish at some stage. Now, running the tool is very, very easy. It just takes a simple JSON or YAML file as input and spits out a PDF with some of the information I've just gone through, and an HDR histogram graph that lets you very easily see how your API performs under load. You can see an example of that graph here on the bottom left corner of the slide. It just shows the latency against the percentile, with some lines indicating the 99th percentile and the real-time threshold at 30 milliseconds. And as you can see, the API I was querying when creating this graph performs way below the 30 milliseconds threshold that you can see at the top of the graph. But let me give you guys a real quick demo of that tool in action, just to show you how you can use it and whatnot if you guys wanted to check it out at some stage. Now, this is where I usually will include a cute cat gif and be like, I pray to the demo gods for everything to work, and hopefully nothing will break, because live demos, as we all know, work 50% of the time, every time. But what I've done instead is I've gone ahead and recorded the couple demos that you'll see through the presentation as a video. So let me go ahead and pull up the first video demo. Let's see, it's loading. Okay, it should be here. Yep. Okay, let's press play. With the output. Okay. So first we have, I'm just showing you guys the GitHub repository for the RTAPI tool. No, I don't have it important, but just remember it's free, it's open source, it's on the NGINX and GitHub repository, GitHub organization, not repository. And then, let's see if I can skip ahead. Maybe not. And then this is the Formula One API that I've deployed as my API endpoint to get data, Formula One related data. I'm just mentioning it real quick because it's open source, it's also available out there. It'd be amiss not to say that that's what I was using. And now let's go to a terminal. I've deployed an instance in AWS, an EC2 instance, TT to the medium, and downloaded the RTAPI tool into that instance, the latest release 0.2, if I recall correctly. I'm first going to query real quick the API endpoint that I've deployed using that Formula One API that I was just sharing. As you can see, I get the data out of it and returns some of the drivers' data, Formula One drivers' data. These were all quite old drivers by now. But still, just showing that it works, it returns data as JSON, you can parse the JSON data, whatnot. Then doing a last real quick, you can see what's in my directory. I have a couple JSON files that I'll be using as input into this demo and the next one. And then the RTAPI binary that I'm going to be using to actually run the commands. Okay, and now I'm going to show you what's within the API endpoint JSON file. This is just a target and a URL. That's all that file contains, because all I'm doing is sending a simple GET request to the endpoint that I was just showing. This is just showing you that your RTAPI tool, how it works. It takes either a file or a data as an input, file as an input, or a data string as an input, and then you can either print the data to the terminal, which if you do that, it'll be more technical data, or you can output a PDF that includes an HDR histogram like the one I was showing before, and some information about why real-time APIs matter, similar to the information that I've covered before. So let's first use the API endpoint JSON file and print the data to show you guys what it looks like, more technical data. It takes about 10 seconds to run, give or take. You can see if you print it to the terminal, it includes a brief description of, again, why real-time APIs matter, a couple of links to get more information, and then you can see the latency of this API, which if you're looking at the graph, well, not really graph, the data that's being output at the 99th percentile is 5 milliseconds. And the mean latency is 2.6 milliseconds. And the other important data to look at is the success ratio, which is 100%. And the status codes that are being returned are all 200s, which makes sense. That's how a working API should work. You should be getting if you're only sending a GET request, by all means, you should mostly be getting 200 as a response code. So now let's go ahead and do the same thing, but instead of printing it, I put it in the data as a report. Looks like I made a typo in the recording. Whoops. Again, it takes a little bit longer this time around because it also has to generate the PDF. And as you can see, it generated the PDF as expected. So now I'm gonna, since I cannot really open a PDF within the AWS instance, I'm gonna SDP the file to my local computer and open it here. And that's the report it generates. As I mentioned before, it includes a lot of information about APIs and real-time APIs, why 30 milliseconds is, we think that 30 milliseconds is a good threshold for defining a real-time API. And then at the bottom, you can see the graph that it generates. In this case, you can see that the latency to 99th percentile was 5.044 milliseconds. And also worth noting, you can query multiple APIs at the same time. It'll generate various lines. There's a little legend here at the bottom right corner. Okay, so that's the end of this demo. Let's go back to slides, back to KitKat. And let's keep moving forward. So the question now is, we've gone over why real-time APIs are important, why you should try to make your API be real-time, be high performance, have full latency of 30 milliseconds at the 99th percentile from end to end, from client request to client response. So the question then becomes, how do you achieve minimal latency? How do you make your API the Formula One car of APIs, to keep with the Formula One analogies? Well, easy. You use the patented Formula One NGINX on your API. Now, for those of you that don't know much about NGINX, NGINX was created in 2004 and quickly gained popularity as the fastest web server within the community. Over the years, its popularity has kept on increasing, and as of today, it's the #1 web server in the world. And there are plenty of good reasons for that growth. First, NGINX is fast. Even with a single CPU processor, NGINX is capable of processing around 100,000 HTTPS requests per second. Second, it's small. NGINX Plus is around 8.5 megabytes in Alpine Linux 3.11. So NGINX is fast, it's lightweight, it's widely used all around the world. It keeps growing in popularity, as you can see in the previous graph. So, what happens if we decide to use NGINX as your API gateway? After all, NGINX also has reverse proxying and load balancing capabilities. And what is an API gateway if not a featureful reverse proxy? And if you even use NGINX Plus, NGINX commercial offering, you have access to state-of-the-art features such as native JOT support, which is key for API gateway management. But okay, wait a minute, I just mentioned API gateways a couple times, and I've only been talking about APIs up until now. So what is an API gateway? Well, in short, an API gateway is a way to control access to your APIs. Traditionally, the only responsibility of your API endpoint should be to serve and handle data. Say you want to add a layer of security to your API or load balance between multiple API endpoints to prevent your endpoints from running out of bandwidth to process your API requests. That's what you will use an API gateway for. There's other reasons too, such as centralized login, enabling rate limiting, request routing, manipulating your requests and responses, or also known as response transformation or request transformation, data transformation, or TLS termination if you want to make sure that your API endpoint is TLS secured. But where do you put your API gateway at? Well, there's no right answer to that question. It really depends on your use case. You could have an API geteway, single API gateway through which your request to various APIs flow. Cheers. Let me see if I can get this to draw real quick. Okay, I can't seem to get the draw feature, but just look at the NGINX Plus gateway that's next to the Warehouse API or the other API. That's kind of an example of what an edge gateway would look like. Or you can also just have your API gateway cover both use cases, like put an API gateway right where the API client meets the Warehouse API and the other API. Or alternatively, if you want to achieve maximal control over your API endpoints, you can also have micro API gateways in front of each of your API endpoint services. Just what you can see at the right part of the diagram. There's an NGINX Plus gateway in front of the inventory service, in front of the pricing service, and in front of the other service. This use case made all the much simpler thanks to NGINX high performance and low hardware requirements, enables all your API endpoint services to easily communicate with each other at their core level, while still maintaining all the advantages of using an API gateway. You can almost say that using micro gateways within each service enables you to almost but not quite achieve a service mesh-like environment. And what makes NGINX API gateways special? Well, I don't really want to showcase our TAPI again. I do have a graph data generated by querying Formula 1 endpoint behind an NGINX Plus API gateway. And as you can see, the performance actually is a little bit better even than the performance you'd get querying the API endpoint directly. The reason for this really is just that NGINX Plus has excellent caching capabilities, which really helps fasten requests that get the same endpoint data over and over again through a short period of time. It should really come as no surprise then that based on some user surveys we've done, around 40% of NGINX deployments are used as an API gateway. Okay, so I have tons of API endpoints and quite a few API gateways in production, and I keep losing track of what's what. And I mean, let's not even talk about how hard it is to push updates to all the API gateways that I have everywhere around or scattered. I mean, what can I do really if that happens? How can I simplify managing all these API gateways? Well, the answer is really simple. You get a solution to manage your API gateways, an API management solution. So what is an API management solution? Well, it's obviously a way to manage your APIs. That's implicit in the name. But what does that mean in practical terms? Well, let me use a sports analogy to go over this, since, an API management solution is not unlike a sports stadium. The core of an API management solution is the control plane, or in the case of a stadium, the ticket booth. The ticket booth is where you set the policies of the stadium. You set who enters the stadium, depending on whether to buy a ticket or not, and the rules by which they must abide, and the stadium if they want to remain in the stadium. Or even if they want to access the stadium, really, maybe they don't let bottle caps, maybe they don't let big backpacks you be carrying inside. There's all sorts of policies that can be enabled. And in the case of an API management solution, the control plane is where you decide who can access which APIs can be accessed, how it can be accessed, and via which methods they can be accessed. Similarly, there's the data plane, which in a stadium is really where ushers enforce rules that have been dictated by the ticket office. It's the responsibility of ushers to enforce who is able of going through turnstiles, who can go through the gateways, because there's even gateways in stadiums sometimes, and who gets kicked off. And in your API management solution, your data plane is the API gateway, which we've just gone through. And as we've covered, it's the API gateway's responsibility to decide to actually act upon what the control plane decided and, either let API requests go through or not, or like handle how they go through via which methods they can go through. In short, really the main responsibilities. Oh, hey, another poll. So as I go over API management and what it can be used for and whatnot, if you guys will answer the poll that just gets sent out, there's really a lot of concerns when deploying APIs into production. I'm sure at least everybody has run into one of these concerns beforehand. There is security, performance, latency, monitoring, analytics, API documentation, complex API management solutions. Sometimes it's very hard to, set your API management policies. If the UI or the platform where you're creating your APIs is lackluster, or sometimes the API management solution that you're trying to use doesn't really support using managing API gateways in cloud environments or microservices, containers, Kubernetes, whatnot. So back to API management. In short, really the main responsibilities of an API management solution include the ability to create and publish multiple APIs and definitions quickly and easily. These API definitions are then obviously published to your API gateway to actually act upon. An API management solution also grants you key operational metrics into how each API gateway is performing, and hopefully if something's wrong with your API gateway for some reason, there's a bottleneck, your API gateway instance went down, whatnot, the API management solution will also make sure to alert you about it. And then at the same time, also gain key API performance insights is a key feature of a good API management solution, especially if your business is based around selling access to APIs. Well, you want to know which APIs are performing better than others, and that will let you know which APIs you should focus more on and which APIs might need to be worked upon to provide a better commercial offering to your customers. And then finally, a good API management solution also includes a dev portal with onboarding and documentation about your APIs and how they work. This will help your API flows to be better understood by newcomers and by developers that are gaining access to your API from a reason or another. And a good dev portal also might include some features such as an API builder in case you're not an advanced tech person and you need to develop your own API for whatever purpose. Probably just drag and drop some boxes all around and create like an API from scratch without having any technical know-how. And of course, all of this within your API management solution should be within a single centralized point of control. Otherwise, kind of defeats the point of having a centralized API management point. So we've gone over why NGINX Plus is a very good API gateway, and I've just talked about the benefits of API management solutions. how do both of these concepts fit together within the NGINX story? Well, I'd like to introduce NGINX Controller. NGINX Controller is a recent offering by NGINX, a commercial-grade offering worth mentioning, and it provides a centralized monitoring and management platform for NGINX Plus that allows you to manage hundreds of NGINX instances within a single centralized platform. And turns out it also comes with an API management module. NGINX Controller's API management module is a very fast API management solution. It combines the power and efficiency of NGINX Plus as an API gateway that I've just been going through, with an all-new control plane functionality, which I'll go through in a second. It also provides a simple GUI from within which you can define, monitor, and analyze your APIs, an external-facing API to pull metrics into your monitoring solution of choice, should you choose not to use NGINX Controller's built-in monitoring features, which it also includes. And more importantly, NGINX Controller is not a software as a service, it's a platform as a service, so you can easily plug it into on-premise or multi-cloud environments. You can deploy it wherever you want, however you want. The most important takeaway, though, is that NGINX Controller API management the NGINX Controller API management solution lets you do all the features I described over the past couple slides, while still retaining 100% of the NGINX Plus API gateway performance. Now, I'm not going to drop any names in this presentation, but if you've ever used other API management solutions, you probably know that API performance can sometimes be severely impacted by those API management solutions and their control planes. So, how is it possible that NGINX Controller, the control plane, doesn't really have any effect on the data plane, the NGINX Plus API gateways? Well, it's really simple, really. It all comes down to its innovative control data plane architecture, a decoupled architecture. So NGINX Controller eliminates the need for local databases or additional components that may introduce complexity, latency, and potential points of failure. And it does that by decoupling the control plane from the data plane. Now, traditional API management solutions have a coupled control and data plane, where each request really has to go through both planes before reaching the API endpoint and returning the API data to the API client or API consumer. When using NGINX Controller, the control and data plane are totally decoupled. NGINX Controller acts as the control plane, and then pushes an irrelevant API policies and definitions to the NGINX Plus API gateways, which act as the data plane, and in turn, they also become the single point of contact between your client and your API. In practical terms, this means that you don't have to go through all the fuzzle of the control plane. Just go through an NGINX Plus API gateway, and as we've seen, the performance of an NGINX Plus API gateway is very good. So altogether, what this ends up meaning is that NGINX Controller will enable you to deploy real-time APIs, and with that, achieve all the benefits you get from using a real-time API. Okay, so I've been talking for a while, so let me finish the major principal part of the webinar by showing you a real example on how easy it is to use NGINX Controller to deploy an API gateway in front of one of your API endpoints. So let me load it real quick. Controller demo. No cat pics this time. Okay, should be showing up on your screens. If listening, let me know if it's not showing. So let's start by going over NGINX controller. This is the main. Okay, I had too far. Oops. Display. Okay, play. Pause. Well, since you go with a bit of latency, so try this again. Okay, there we go. This is the landing page of NGINX controller. As you can see, it gives you an overview of how your NGINX Plus instances are performing. It should be worth mentioning that this NGINX controller that you're seeing right now was hosted on AWS. Same way as the NGINX Plus instances that I'm going to be using as an API gateway. The application health score, green box that you can see here, just tells you how your NGINX Plus how the NGINX Plus instances managed by controller are performing, and if they're acting healthy or not. In this case, it shows 99.9% because I had been doing some fiddling with it before recording the demo. But hopefully, if you have a good enough setup and your APIs are performing, you want this all to be 100% all the time. So now let's go to infrastructure. And here you can see that just one NGINX Plus instance connected to controller right now. The name is the AWS instance ID. And you can also view some graphs to get a better insight into how your API is performing. Yeah, your NGINX Plus instance is performing. And some info about how the NGINX Plus configuration works. It'll show you if it has SSL set up, how many locations, substreams, if there's any errors, which servers are set up. It gives you a quick insight into the configuration of your NGINX Plus instance. So to deploy an API gateway, what you do is you go to Services, APIs, API definitions. You create a new API definition. I'm going to name my API definition Formula 1 API definition. I'm going to keep names very simple throughout the whole demo. And the base path is going to be /API/F1. I'm going to only create a URI for this actual API definition for demo purposes. It's good enough to show you how it works. Querying to drivers endpoint. That the same endpoint that I was showing in the previous demo. As you can see, you can also select the path prefix that you're going to query. If you use prefix wildcard, what this means is that it will query anything that's past the driver's endpoint. That past the driver's URI too, if your request includes any more data. I'm using prefix in this case because that way I can ask for data to be returned in JSON format by appending .json to my request. Otherwise, you could also show exact, in which case, if you choose exact, literally only the proper driver's endpoint will be allowed to go through. So now let's go to publish my API. You'll see it's asking me to select an environment, an application, and a gateway. I haven't created any of those yet, so let's go ahead and create them. Start by creating a Formula 1 environment. Once again, keeping the simple names, it's just going to be named Formula 1-environment. Then skip into the description and tags of all these various components that I'm defining for simplicity's sake. You also need to create an app that lives within your API, within your environment. And you can have multiple apps for environment and whatnot. You can customize it to your heart's desire. And then the final thing is defining a gateway. The gateway will be basically defines how the API, how your NGINX Plus will act as a API gateway. For example, right now, you can see that I chose the instance that I was going over before, my infrastructure. This means that this gateway configuration will be placed within the NGINX Plus instance that I've connected to controller. I've gone ahead beforehand and also added a registered and alias record with this instance to showcase more of like a real life scenario where your API gateways might actually have some DNS records attached to it. And I've also created some certs for it just to make sure, well, to enable HTTPS really. I'm just going to go ahead and create import these certs real quick. And as you can see, you can customize all sorts of settings for your gateway and how SSL is configured, but I'm going to skip all of that. Also methods and whatnot. But once again, for purposes of this demo, they're not really necessary. Finally, yeah, just hit submit. The gateway will be created successfully. Let's go back to API definitions. Set everything that was just created. And let's create a policy too, because let's assume it's an internal API, you want to add some authentication to it, make sure that only people that are authorized can access it. One of the most popular ways to do this nowadays is using a JOD token, JOD authentication. So I'm going to go ahead and create that. Once again, deploy everything within my Formula 1 environment. And I have some a JSON web key already created. I'm just going to paste it real quick. And let's go back and create the policy that I just created. Then you can choose where you want the token to be presented. I'm just using the bearer token because that's the standard. And then finally, let me go back a little bit if I can. There we go. Finally, you need to route the URI that you created, the driver's URI in this case, to where your API, the actual data, lives. And you do that by first creating a workload group, which is, and a different way to name it probably will be like where your API endpoint, your URL lives, or the IP where it lives. So let's go ahead and create that. And I'm going to use the API endpoint that I created that you saw in the previous demo that contains the Formula 1 API data. I'm just going to type in the URL. Let's set port 443 since it's an HTTPS endpoint. Let's click save and then publish. This sometimes takes a little bit of time. Just gonna give it a few seconds. And then let's see if it works. I've already pre-made this call, well, pre-written this call in my terminal. It takes a while to format, but it includes the bearer token that you need to authenticate. And yeah, as you can see, it works. Everything's working as expected. You get the data, it's some data I was getting in the previous demo, but this time it's going through an NGINX Plus API gateway that uses JOD authentication, an HTTPS gateway too. So let's use RTAPI again to test the performance. This time I'm using a different JSON file, an API gateway file. So you can see it has the URL, and it also includes the bearer token that you have to use to authenticate. And let's print the data. And there you can see the performance at 99% with 3.34 milliseconds. Again, faster than the performance would get if we were querying the API endpoint directly, which is great performance. And still, the success ratio is 100%. Status codes are 200. all around. So let's create the PDF, then I'm going to show you the report real quick. Let me skip ahead for timing purposes, if it works. There we go. So this is the PDF report the graph that you'll see in the PDF report if you were to print it from that API endpoint. I mean, the latency varies a little bit between each load attack, but which makes sense. But it is around at the 99th percentile, it's 3.323 milliseconds, which again is great. It goes above the 30 milliseconds threshold, around the 99.99 percentile, but that's not that bad as far as performance goes. Really, what you really want to care about is the 99th percentile. So that's that for the demo. We see now to deploy. Hopefully that helped drive home how easy it is to deploy NGINX Plus as an API gateway using NGINX controller, and how NGINX Plus enables you to achieve high-performance real-time APIs. And with that being said, and since we're also running out of time, let me go over a brief recap, which basically is if there's only 3 things you could take away from this webinar, hopefully let's make it this 3. Number 1 is that there are 3 pillars of the API hierarchy: API management, API gateways, and API endpoints. You can use NGINX controller as an API management solution. You can use NGINX Plus as an API gateway solution. And, well, I mean, you can really use whatever tag fits your use case as your API endpoint. But hopefully you'll use NGINX Plus and NGINX controller to fill your whole API solution. Second, NGINX controller has an API management module that enables microservices-friendly API management. I should mention, which I have not, that the Formula 1 API that I've deployed as part of this demos is actually a set of Docker containers running as microservices. And you could also just deploy NGINX Plus as a microservice, and the workflow will be the exact same workflow that you've seen me go over in the demo. And yeah, it's basically it. Really, just very good microservices from the API management. And then the third key takeaway is that NGINX Plus really can act as a very highly performant real-time API gateway. And trust me when I say it, there's not that many API gateways that have the performance that we have. Or, to end on a funny note, as my dogs will say, NGINX are kind of like speedhounds, just running all around to make sure that your API gateways perform as efficiently and as fast as they can. And that's that, the end. And we have 3 minutes left in case there's any questions. Okay, looks like we're out of time. So, I'm sorry about that. There's no time for... Guess that's that then. Oh yeah, we have $50 software too that go towards the swag store. We have pretty cool swag, like a work from home shirt, which I'm actually wearing right now. So feel free to use that code and go get some nice swag for yourselves.
Alessandro, thank you very much for the great presentation.
Thanks.
I just wanted to remind all of our attendees first wanted to, before finishing up, I wanted to thank you as well as NGINX for being sponsor of today's online learning session. And I wanted to remind all of our attendees that there is a recording of the sessions the session will be available in 24 to 48 hours, and you can forward that on to your coworkers. This recording will be added to the devnetwork.com and developerweek.com content archive for future viewing. You can also, tomorrow when you get the email, or in 24 to 40 hours when you get the email, there will be contact information. So if you have additional questions for Alessandro or for NGINX, please make sure that you do respond to that email and include those questions for NGINX. Thank you very much to all for participating, and have a great day.